Okay, we are going to dive into our second lesson on graphing. This is most relevant for Math 053, Chapter 4, and we're going to actually cover all of Section 4.2 and 4.3. This is a big one here. Um, there, this type of there is basic graphing in some of the other courses you can see there, but we're already beyond what you would see in 038 or 026 as we do this. The one thing that does come up as well in this lesson is there will be frequent situations where we have to do some basic equation solving, and that is something you do need in Math 052 in particular and a bit in 038. So if you're here with us or watching this and you want to just practice solving the equations and not worrying about the graphing part, that's something you could do if you want. So last time you remember, let's just recap. The graph of a linear equation is a picture of all of the xy pairs that make the equation true. And when I say make the equation true, what I mean is simply it makes the left side of the equation equal the right side of the equation. So that's the example we spent a bunch of time on last day to develop this idea. And you see there, that's the line we came up with. And where did we get that line? We got that line by coming up with a bunch of points that where x plus y was equal to 10. Things like 8 plus 2 and 3 plus 7 and 5 plus 5 and even negative numbers, fractions, decimals, everything in between. So what I think I've done there is I've grabbed any random point that I can see is on the line, and this point looks like it's 3 to the right and 7 up. So that is the point 3, 7. So if what we're saying is correct, then 3 plus 7 should equal 10. Does 3 plus 7 equal 10? Sure, it does. So, as we said, any point that is on the line makes the equation a true statement. Or there's another one, 10 and 10, 0. When x is 10 and y is 0, we can see that's another point that's on the line. Does 10 plus 0 equal 10? Sure, it does. Once again, any point I find anywhere on that line, even weird decimals or fractions or negative numbers or anything, even going way, way, way off in this direction or way, way, way down in this direction, every point on that line will make the equation x plus y equals 10 true. So the opposite is true as well, we saw. So if I can come up with any pair that makes the equation true, 6.5 plus 3.5 equals 10, then that pair should be on the graph. And again, you see, sure enough, there it is. Every point that's on the graph makes the equation true. Every point that makes the equation true is on the graph. And then the last thing, no, not the last thing, we got negative 2 plus 12. There's another pair that makes the equation true since negative 2 plus 12 is equal to 10. So that point had better be on the line. Yep, there it is. Sure enough, 2 to the left and 12 up. What about a point that's not on the line? So there we have 9, 8. 9, 8 is not on the line. Therefore, 9, 8 should not make the equation true. Great. 9 plus 8 is 17, which is not 10, right? So the only points that make the left side equal the right side are the points that appear on that line. And that's why that line is the answer to the equation x plus y equals 10. The second thing, the big takeaway we came up with at the very, very end of last lesson was that in order to draw a graph, we don't need to get 4 points or 10 points or 30 points in order to draw the line. All we need is 2. If we had any 2 of those points, so if we had only figured out those 2 points, then that's enough to pick up your ruler and your pencil and draw that line. Or if we'd only figured out those 2 points, that would have been enough to draw the line. So the goal here right now is to find how are we going to find those 2 points so that we can draw the graph of the line. So for instance, say we are asked to draw the graph of y equals 2x plus 3. So what we're going to do here, we discovered a few ways to do this last time, but what we're going to do is we are going to start picking some values either for x or for y, whatever looks easier, and we're going to calculate the other one that goes with it. So here I've picked a value of x equals 0. I'm going to figure out the value of y that goes with it. And we talked a little last time about how this kind of throws students because they're like, wait, how can you just pick any numbers you want to? I can pick any numbers I want to because I am going to pick an X and find the Y that goes with it, so I know that that pair is on the line. Or I'm going to pick a Y and find the X that goes with it. Now I've picked 0 because why not? It's a nice easy number. Why would I pick a hard number? Why would I pick X equals 2.731 and find the Y that goes with that when I could pick 0 and find the Y that goes with that? So I take that 0, I plug it in for X, and 2 times 0 is just 0. 0 plus 3 is 3. And there we go. There is my first pair. When X is 0, Y is 3, makes the left side of this equation equal to the right side. Okay, what next? Well, 0 is easy. How about we try 1? So we stick a 1 in for X. 2 times 1 plus 3 appears on the right. 2 times 1 is 2. Add 3 is 5. Boom, there we got 2 points that are on the graph. When X is 0, Y is 3, makes the equation true. And when X is 1, Y is 5, makes the equation true. Makes the left side equal the right side. So there's the 2 points I'm going to use. Let's go over to a grid and put those 2 points on. You see I got 1 in red and 1 in blue. And there they are on the graph in red and blue. And if you were doing this on paper, you would now just pick up your pencil and your ruler, set the ruler across those 2 points, and draw your line all the way to the edge of the graph in both directions. If you're doing this on a program like MyOpenMath or Pearson MyMathLab, then you just need to identify those 2 points and it will draw the line that goes through those points for you. So it's actually even easier. Now those are the 2 points I got. We could have found some others. For example, I might have tried sticking in X equals 2 and I would have found out that Y equals 7 when I do that calculation. Or I could have stuck in X equals -1 and I would have got out Y is +1. 2 times -1 is -2, plus 3 is +1. Or I could have stuck in X equals -2 and I would have got out Y equals -1. All those points are on the graph as well. Any of those I could have got. So you see, it doesn't matter which 2 I pick, because once I do the calculation, I will have a pair, an XY pair that is somewhere on the graph. So pick the ones that seem easiest and then calculate the Y that goes with them. Or in some cases, you'll find it's easier to pick a Y value and find the X that goes with it. Either way, get any 2 of those. And if you want to get a few more, it doesn't hurt, because then you can double check yourself, right? Because they should all fall in a straight line. Okay, so pick values that result in nice points. So we're really getting into the 4.2 section stuff here now, because sometimes you can plug in some X's or Y's and do your calculations, and you get out ugly points, things with fractions and decimals that are basically impossible to graph accurately. So you want to try and avoid fractions or decimals when you can. So let's start again with X equals 0. Why not? It's really easy, right? So I'm going to go over this equation, and I'm going to replace the X with a 0. And then I'm going to calculate the Y that goes with it. So 2 times 0 just disappears, so this just becomes 3Y equals 12. You can see why the zeros are so easy, right? Divide both sides by 3, and we get Y equals +4. There, that's a nice point that we got. So it seems no problem, just like last time. Last time we tried X equals 0, and then we tried X equals 1. Why don't we do the same thing? So let's take X equals 1, plug it in. 3 times Y minus 2 times 1, so we replace the X with a 1. Seems fine so far. 3Y minus 2 equals 12. We know what to do there. Add 2 to both sides, so we get 3Y equals 14. Divide both sides by 3. Uh-oh, we have a fraction. Now, this point, so 14 over 3, which is 4 2/3. This point, when X is 1 and Y is 4 2/3, is legitimately on the line. It's there. It's just going to be almost impossible to graph that accurately, because when you try to go to Y equals 4 2/3, you're guessing, right? You're partway between 2 lines on the grid, and you're taking a guess, and you're not going to get an accurate graph. So let's go back to the drawing board. That point is true, but it's not going to help us. Let's try and figure one out that is not a fraction. And now look at what caused this to be a fraction. What caused it to be a fraction here is that this number ended up being something that doesn't divide by 3. So we might keep that in the back of our brain. Let's try x equals 3. And the reason I did that, you can see the 12 is already divisible by 3. If we can make this number here that is formed also divisible by 3, then our answer should be divisible by 3. Now, if you didn't quite catch that logic, don't worry. You just sometimes have to try a few. So you might have tried x equals 2 next, found that it also gave you a fraction. Try x equals 3, and there's the solving. 18 divided by 3, there we go. Y equals 6, a nice whole number. Sometimes you got to try a few, but what you will find is as you practice them, you'll get better and better at seeing what numbers are going to be good and what numbers are going to be bad. And as soon as you can see that it's going to be a fraction, just stop with that number and go back and try a different one. So there. Now I've got 2 points. Those would be perfectly good to graph the line. I am going to find one more here just because I want to show you something. Probably easier than fiddling around to find another x value that worked would have been to first try y equals 0, because we know the zeros are really easy to do. Now, sometimes it could result in a fraction anyways, in which case you have to go find something else. But in this case, it works great. So I put a 0 in for y, and now I'm going to solve for x. Divide both sides by -2, and I get -6. So any two of those 3 points would work. Let's just, for fun, yeah, any two of those would work. Let's just take the first one and the third one we got, but you could also take the first one and the second one, or the second one and the third one. So let's put 0, 4, and -6, 0 on the graph. There they are. 0, up 4, and -6, 0, so left 6, and not up or down at all. There are the 2 points. Draw the line between them, and you have your graph. And let's just take a look at that other point we found. Yeah, it's there too, 3, 6. It's also on the line, so I could have easily used it once I had found it. What I wanted to demonstrate to you there by going on and finding the other one was just how easy the zeros are when you're able to make use of them, which isn't always, but often. And oh yeah, there's that other point. Remember we found that point? Here, let's backtrack. And we said, oh, we don't want to use that one. There. When x is 1, y is 4 2/3, right? It's true, it's on the line. It just wasn't helpful because it's hard to graph. But look at our graph. It's on the line when x is 1, so to the right 1, and y is 4 2/3. So up 4 2/3 of the way to 5. There it is, right there. All the points that make the equation true are on the graph. It's just if they have fractions, they will not help us get a good picture. So we need to find nice whole number versions. Okay, so here's another one where we're going to run into some fractions. So y equals 1/3 x minus 1. Let's take a look. Well, trying x equals 0 seems to be working great, so let's stick with that. I'm going to replace the x with a 0. Oh, well, isn't that nice? 0 times 1/3 is 0, so that just wiped our fraction right out. Perfect. So y is -1. So there we have a point that makes the left side equal the right side, so it will be on the line. What are we going to try next? Well, let's try x equals 1 again, because the first time it worked, right? Why not? 1/3 times 1 minus 1. Now, I'm going to stop right here. Actually, I don't think I am, but I would stop right here because I can see right now that I'm going to get a fraction answer. So you can see I did 1/3 times 1, which is just 1/3. And remember, though, you're technically doing fraction multiplication there. Multiply the tops, multiply the bottoms. 1/3 minus 1, you'd have to do some common denominators there. 1 becomes 3/3. 1 minus 3 is -2. You can try that on your own later if you want. So there we have a true point. When x is 1, y is -2/3, but not a helpful point because it's going to be too hard to draw that fraction. Okay, let's try something else. So here is where I would really look at what's going on. What caused this to be a fraction? when I went 1 times a third, I got a fraction. So if I could pick something for x that makes the fraction go away, and that's going to be something that divides by 3. Probably the easiest would actually be 3, but I've decided to use 6. And if you're not quite sure why I made that selection, watch what happens. It'll make sense. I replace the x with a 6. For fraction multiplication, that 6 becomes a 6 over 1. Multiply the tops, multiply the bottoms. Bingo, 6 over 3 is just 2, right? So I purposely picked an x value that makes my fraction cancel out. And that gets me a second point on my line. When x is 6, y is 1. Okay, so we've seen a couple options there, how fractions can appear. You want to stop when you see the fraction answer happening, go back and try a different value. And sometimes that means trying a y instead of an x, or sometimes it means trying an x that you can see will make the fraction go away. Sometimes it just means taking some guesses until you can find one that works. Sometimes there's just no real way to spot what's going to work and what's not going to work. You just have to try a few till you get one. So there we have whole number points, 0, -1, and 6, 1. There they are on the graph. 0, -1, and over 6, up 1, 6, 1. Pick up your pencil and your ruler if you're doing this by hand, or if you're using an online utility, just tick those 2 points and it'll pull the line through them for you. And I think I'm probably going to show you that that other point we found is on there. Yeah, sure, there it is. Remember the point we found that we didn't want to use when x is 1, y is -2/3. There it is. 1 to the right, 2/3 down, on the line, just too hard to graph accurately. You want to be right on these crosshairs when you're doing these graphs. Okay, so that is the basic idea that you're going to be doing in all of section 4.2 pretty well, other than one little thing at the end, which we're going to talk about in a few minutes. Section 4.3 is really just more of the same. It's just a special case of the same. So remember in that first example, we saw how easy it was to use x equals 0 and solve for y, and then y equals 0 and solve for x, right? When you choose those 2 points as your 2 points to find, that is specifically called graphing by intercepts. Let's try one, and then we'll talk about why it has that name and what intercepts are exactly. So here we have an equation, and by the way, this is a perfect setup for graphing by intercepts. Let me quickly tell you why. Take a look. All the x's and y's are on one side, so it's nice and easy to plug in zeros and solve for the other one. And look at the numbers. 12 divides by 6 nicely, and 12 divides by 4 nicely. So all the answers are going to turn out to be nice whole numbers. So let's take a look. We are going to graph by intercepts. That means we are going to plug in x equals 0 and find y, and then we are going to plug in y equals 0 and find x, and that will be the 2 points on the line. So this is nice and easy because we plug that 0 in and poof, it just disappears, right? 0 times 6 just goes away. So -4y equals 12. Divide both sides by -4 because they cancel. So there's our first point, y equals -3, goes with x equals 0. And let's try the second one now. So now we're going to take y equals 0. So you see I put the 0 in for the y that time. And again, poof, it just disappears. So we just have 6x equals 12. Divide both sides by 6. X equals 2. You can almost do these guys in your head. Just be careful about the negatives. So x equals 2. There is our 2 points. Put them on the graph. There they are, 2 to the right and 0 up or down for 2, 0. And 0 left and right, and 3 down for 0, -3. And draw the line through them. Okay, why is it called graphing by intercepts? Well, notice that 2, 0, that one point we drew, is where the graph crosses the x-axis. This guy here is the x-axis, right? I didn't label him on this graph, but with the horizontal is the x. So one of the points we got when y is 0 is where the graph crosses the x-axis. we call that the x-intercept. The other point, 0, -3, is where the graph crosses the y-axis. We call that the y-intercept. So where it intercepts the x-axis and where it intercepts the y-axis. So when we plug in zeros for x and y, when we plug in a 0 for x, we get always, if x is 0, think about it. If x is 0, we haven't gone left or right. We get a point on the y-axis. We get the y-intercept always. When we plug in y equals 0, we get a point on the x-axis always. We get the x-intercept of the line. And in fact, you can find these without even drawing the graph, right? If they just say, here's an equation, right? Give you this equation, and they say, what's the x-intercept? You don't even have to draw the graph. You just plug in y equals 0, and you get the x-intercept. Or plug in x equals 0, and you get the y-intercept. So that is why this method is called graphing by intercepts. Plug in 0 for each variable, solve for the other one, and you will have the places where the graph meets each of the two axes. This method will always work even when it's not a nice equation like this, although again, if you get fractions, that's no good because it's going to be hard to graph them accurately. There is one situation where this method will not work. I'm going to give you 30 seconds, 20 seconds to think about that. What is the one type of line where this would not work? Well, okay, I can actually think of a few others you could argue, but there's one main one. The answer is if your line goes right through 0, 0, because then the x-intercept is 0, 0, and the y-intercept is 0, 0. That's only one point. You still need to go find another point in order to graph the line. Okay, what else we got here? So we can, we've already said this. We can find the x-intercept by plugging in y equals 0 and solving for x. In this case, it was 2, 0. We can find the y-intercept by plugging in x equals 0 and solving for y. Here it was 0, -3. X-intercept and y-intercept come from the other variable being 0. Okay, our last little idea for this lesson, and this one's tucked right in at the end of 4.2. Wow, there's a big cat fight going on outside. Wow. The last little idea we're going to talk about is horizontal and vertical lines. So there are some lines that only have an x-intercept or only have a y-intercept. How could that be? Well, there they are. Look at that first line. It is straight up and down, a vertical line. It never meets the y-axis. And the second one, horizontal line, straight left and right, it never meets the x-axis. So these lines only have one intercept. And they have a very special type of equation. So yeah, vertical line has an x-intercept but no y-intercept. Horizontal line has a y-intercept but no x-intercept. And yes, these lines turn out to have special equations. The equations of these lines are missing an x or a y. All the equations we've done so far have both the x and the y in them. But if the x value doesn't matter, right? Look at this line. All that matters is the y value. It's irrelevant what the x is. Then there's no x in that equation. This line here, it doesn't matter what y is. It doesn't matter how high or low you go. X is always 2. So let's look at these separately. Yeah, so there's some points on this vertical line. Notice about every single point, doesn't matter what y is. Y is 3, y is 1, y is 0, y is -4. Go up 1,000, y is 1,000. Go down 1 billion, y is -1 billion. Doesn't matter what y is, x is always 2 on this line. And therefore, the equation of that line doesn't have a y in it because it doesn't matter what y is. What y is doesn't make any difference at all. X is 2. Look at these points. Every one of these points makes the equation x equals 2 true. When x is 2 and y is 3, does 2 equal 2? Yes, it does. x is 2 and y is 1. Stick that into the equation. 2 equals 2. True. X is 2 and y is 0. Stick in 2 for x. 2 equals 2, right? It doesn't matter what y is. X is always 2. That is the equation of a vertical line. Horizontal line is just the same exact idea, but opposite. So there I've listed a bunch of points on this horizontal line, and you can see that no matter what x is, y is always -1. So it is irrelevant what x is. The equation of this line is y equals -1. Now, horizontal and vertical lines, I got one more slide. Oh yeah, okay. So here's a bunch of examples of equations of horizontal lines and vertical lines, right? So there's a line at y equals 3. It just goes straight across horizontally at y equals 3. Y equals negative. So what you see in common for all these lines, there's a y but no x. That means you have a horizontal line. What do you see in common for all these lines? You have an x but no y. That will make a vertical line. They're dead easy to graph, because you just go up to y equals 3, that's the y-intercept, and whoosh, draw a horizontal line straight across. Pick any other point to the right or left if you want. You just go over to x equals 5, so straight to the right 5, that's the x-intercept, and straight up and down all points where x is equal to 5. So horizontal and vertical lines are the simplest ones and cause the most trouble. Let me tell you why. Because over and over and over, you're going to learn to do some complicated thing with equations that have both x's and y's. And then you're going to suddenly they're going to toss in a question that's either a horizontal or vertical line. So it only has y's or it only has x's. And students will try to do the same complicated things with the horizontal and vertical lines, and it doesn't work because the complicated thing you were doing needed both an x and y to be there. So you want to try and lodge this in your brain. And it's going to take a few times. This is going to happen to you a few times, I almost guarantee it, where you're going to be trying to do this and you ask me a question and I say, take a look. Notice the line, the equation doesn't have an x. It only has a y. That means it's a horizontal line. Drop everything. All you got to do is figure out what y is equal to. Same thing if it has an x but no y. Don't try and do all the calculations and everything we're going to be doing later in the chapter. All you got to do is figure out what is x equal to. All right, and I think that's it for our first lesson. We will take a little break, then carry on.